Okay, so rotations. I used to show this with tracing paper. I'm still going to show it to you with tracing paper, but I will, if I can find my triangle, here we go. But I'm going to show you how I do it nowadays. I find that they almost always ask about the origin. It's going to be the point of rotation. So again, a rotation, that T, that's the turn. Your tires rotate. And when you turn, you're going to turn about a point. Now usually they say origin. Remember, origin is where everything starts at 0, 0. So if your point of rotation is the origin, I don't use tracing paper anymore, because as I rotate my paper, usually in multiples of 90 degrees, my axes just swap around. Okay, so I'll show what I mean. So first I want to show you what a turn looks like as far as the direction goes. So as soon as you identify that you're looking at a turn or a rotation, you need to identify the direction of that turn. Okay, am I going to go clockwise or counterclockwise? And the degree of rotation. Okay, so remember, with the reflection, we wanted to know the line, because you're always going to flip over or across a line. Okay, in this case it was that line. But with the rotation, you're turning, and you're always turning about a point, and it's usually the origin. That's going to be the easiest scenario. So with tracing paper, I want to show you that what you're doing is, and the trick if you want to use tracing paper is use an arrow kind of as a guide, just like when you're checking for rotational symmetry to see how far you've turned. And you want to ask yourself, clockwise, what direction is that? So clockwise, if you look at an actual clock, right, with a couple hands here, which direction do the clocks go? At the hands, if you watch them, they go this way. Okay, so that's going to be clockwise. Clockwise, and it's in the direction of the hands. The next question you want to ask yourself is, okay, if I'm going to turn to the right and I'm holding on the origin, 0, 0, where's that arrow going to be when I've got 180 degrees? So 360 divided by 180 is 2 turns. So that's going to be half turn. Okay, 180, a quarter turn is 90, so I'm going a half turn. So that is my answer. Now again, I find these a little tricky to be accurate with the tracing paper, and it's not a tool you can use on the SOL. So here's what I want you to picture. You're just going to use your paper. Okay, again, I wanted you to see what it would look like. I'm going to take it, go clockwise to the right, 180 degrees, arrow's going to point down. That's a rotation of 180 degrees. Okay, pre-image and image. But you're going to actually just take your paper and rotate it. Okay, so line this up with the corner of your paper and ask yourself, where do I turn for 180 degrees clockwise? What direction, how far? 90 is a quarter turn, so I'm doing 2 quarter turns. I'm doing a half turn. So I'm going to take my paper and I'm going to go 90 degrees, and then another quarter turn is 180. And if you're rotating about the origin, this is your answer. That's your actual answer. You can take a scrap piece of paper at your table, write down your new coordinates. So A prime is at 2, 1, 2, 3, 4, 2, negative 4. See, this is now your x-axis. That was positive, that was negative. This is now your y-axis. Up, positive, down, negative. So you're just writing your new coordinates on your image. B is at positive 1, 0. And then C prime is at 1, 2, 3, 4, 5, negative 2. And then you can take your paper and go back to your original picture and write in your new coordinates. 2, negative 4 is where A landed. 1, 0 is where B landed. And 5, negative 2 is where C landed. So again, this is an isometric rigid transformation. Your pre-image and image should look exactly the same if you go draw it. Okay? So let's try one more together. As soon as you identify that you're doing a rotation, a turn, you want to know what direction. Okay, now on this last one, because it was half a turn, it turned out to not be significant. But when you're doing a 90-degree rotation, this is incredibly important, okay, because you will not be correct if you go the wrong way. And then how far 90 degrees is your quarter turn? And you should always check, is it about the origin? Yes, because the origin, if this is about the origin, where this is your point that you are turning about, holding on to, when you do quarter turns, it just switches around your axis. So this technique of just taking your paper and turning it is very, very effective. Okay, it's very accurate. Alright, rotate the rhombus 90 degrees counterclockwise. So counterclockwise. Counter is to go the opposite. So if your clock goes this way, take your hand and follow the clock. Look at a clock in the room. If this is counterclockwise, the other way is counterclockwise. What did I say? This is clockwise. So this is counterclockwise. So I'm going to go this way. Now 90 degrees is a quarter turn. So if I start here at the top, that arrow will be pointing to the left once I go counterclockwise 90 degrees. So take your paper, line it up with the corner. Okay, again, look at that arrow. Make that stand out. Where does that want to go? Where do you want that to go? Where do you want it to be when you're finished? Counterclockwise. Your clock is turning this way, so we're going to go the other way. We're going to go this way. And a 90 degrees is a quarter turn, okay, a fourth of 360 degrees. So it's going to be pointing to the left. You're holding on to the origin because you're rotating about the origin. That's the point that you're turning on. Boom, there's your answer. Okay? You take a separate sheet of paper and you write down your new coordinates. So 1, 2, 2, 4, 3, 2, 2, 0. I turn my paper back around so I can put it right on the same paper there. 1, 2. You know, sometimes you're just asked for the coordinate of one of the pre-image points, so just give that one. You don't have to go through this if they're not asking you to do this. 3, 2. But depending on the question, sometimes you really want to see where each individual point goes. So it just depends on the question how detailed you want to be. So I wanted you to see the pre-image and image together, so I've done the whole thing. Okay, and again, isometric, they should look exactly the same. If you use tracing paper, they should map onto each other perfectly because it's an isometric or rigid transformation. Okay?